Mercenaria, or hard clam, is a very important species for the health of the economy and the marine food web. Growers along the eastern seaboard experience mortality-related loss in their hard clam inventory for several reasons. In northern areas, the pathogen known as quahog parasite unknown, or QPX, creates problems on shellfish farms from Massachusetts to Virginia. In Florida, heat stress during the summer can result in mortalities of larger clams reaching harvest size. These events result in lost revenues for growers. Thus, the Sea Grant Hard Clam Selective Breeding Collaborative, HUB, aims to improve the aquaculture industry on the Atlantic coast by finding and establishing more resilient lines of clams.
Yeah, we're talking about growers, hard clam farmers on the East Coast, and that's what this project's really for. Keep in mind that New York does not have very many hard clam farmers, but pretty much all towns in Nassau and Suffolk have hard clam programs where they either have a hatchery or a nursery. They buy hard clam seeds to put out for the public. And some of this research is definitely germane to that as well, especially the QPX part, where we're looking at disease, because we can get diseases when the clams are kept close together. And by the way, there are a number of oyster farmers that are looking to diversify their crops and to get into hard clam farming. Hard clams have really come up in value over the past few years. Not rivaling oysters, but there's a market for them, and they are wanted in the market.
Researchers have been studying the clam's genome for the identification of naturally occurring strains that are resistant to these stressors. Now, what is a genome? A genome is all the genetic information stored in DNA that describes a living organism, and this genome makes us who we are.
So why is it so important to study the genome of the hard clam? That's how we're going to get at the traits and how we can select for those best traits. And it'd be really easy to take a sample of a clam once we get that, the genome down, like we have for humans, by the way, and find out what gene allows them to survive heat stress better, or this QPX parasite that affects clams in culture conditions primarily. So that's the main reason. Yeah, to make a better clam.
The genome is key for allowing scientists to identify parts of the DNA that control responses against QPX disease and heat stress. The method being deployed identifies an exact location, also known as a genetic marker, on a chromosome that controls specific traits. A trait is the expression of a gene, and this can have physical, metabolic, or immune characteristics. Seemingly minor variations in these genetic markers can create major differences in traits. A team of researchers has successfully completed the first steps to identify these genetic variations at the DNA level within the clam genome that controls response to QPX disease and heat stress. Scientists have sequenced the hard clam genome and discovered millions of small variations in DNA called single nucleotide polymorphisms, or SNPs. Genetic selection is expected to be more precise and efficient than traditional selective breeding. This selective breeding will produce genetic improvements so hard clam growers can reproduce these specific traits in future generations of their crops.
Right, after a number of generations, we want to be able to take these clams that we spawn, and when they grow up to be broodstock, to be the parents, male and female clams, we can provide those to hatcheries up and down the coast. Maybe some of them will be more valuable in Florida than, say, in Massachusetts, which is as far north as we're really going with the project. The hatchery, whether it's commercial or municipal like ours here, we can select for a trait that we want. Like I said, we might not care about the heat stress like they do in Florida, but we're going to care about disease, and we're going to care about fast growth and the shell thickness to keep the predators at bay and to get a clam to market.
Many areas of the domestic food industry use selective breeding to increase production. Selective breeding is different from genetically modified organisms, or GMO. GMO usually involves the introduction of foreign genes that didn't exist previously, whereas selective breeding is based on naturally occurring variations already in the organism. There is still more work to be done, but we hope to soon identify resilient strains that would improve clam farm viability, and from this ensure the availability of high-quality seed to growers.
And keep in mind that New York is, out of the 5 participating states, we are the lowest production in terms of hard clams of those 5, and actually more than that on the East Coast. And it has to do with a lot of factors. That being said, I think this project can help jumpstart the commercial farming industry on Long Island and get more people that are either growing oysters now or just want to grow clams in the future. I think it's going to help jumpstart that. And it could be the next 5 years, so we'll see.